Hi, so my name is Haoyi, and this presentation is, I'm going to talk about 4 facets of what I think make good open source libraries. So these are ideas that are not specific to any particular library or any particular field or any particular language, but are things that if I'm going to use an open source library, what I would want to see in that library. And as someone who writes an open source library, what I try to provide to the users of that library so that they can use it and be happy using it. So a bit about myself. I was previously at Dropbox. Currently, I'm at a small software shop in Singapore called Bright. We do a bunch of data science Scala consulting. And we made a cool tool called the Fluent Code Explorer, which I'm going to pitch here just at the start of the presentation, which is basically an online, it's an online code search tool, kind of in the vein of if you've used Hound or if you've used LiveGrep or similar things. It's like that, but better and faster. So if any of you want the online code search tool, you can come talk to me later. Now that's over with. So I've done a bunch of work for Scala.js, and I've made a bunch of libraries. So that's why I'm talking about writing open source libraries today. So here are some of the libraries I've written. So does anyone here use any of these libraries in their day-to-day work? You want to shout out which ones? Ammonite. Anyone not use anything else other than Ammonite? Scalatags. OK. So I assume if you're using a library, you probably like it because there are other options. And if you didn't like it, you'd probably not be using it. So this presentation will talk about what I did to try and make these libraries nice enough that people like you would like to use them. So what are the goals of an open source library? By my relatively narrow definition, the goals of an open source library is to make something you use, that your friends and your colleagues will use, and that random strangers will use. So someone in China or someone in Romania who you've never met before can pick up your library and be happy using it. If you only want to hit the first 2 points, you do not need most of the things I'm going to talk about in this presentation. But if you want to hit the third point and make something that strangers will use, that's somewhat more difficult than making something that someone sitting next to you will use when they can just ask you questions whenever they have they don't understand it. So non-goals of the open source library, again, as I defined it relatively narrowly, is to go around answering questions, to talk to lots of people, or in general, to build a community. All these are perfectly fine things you can do, but I don't think that they are core to an open source library. So you can have a library without a community. You can have a library with a community. I've used plenty of both. You can have communities without a library. You can have a community about raising chickens in your backyard. That's quite a popular one online. So it's kind of separate whether you're in the community and whether you're in the library. And I think that, from my perspective, a library is something like the thing on your left, which is you want it to be dumb and not very interactive, but solid enough that you can take and build something more interesting out of it. So the library itself is not meant to be challenging or difficult or impressive. The library itself is just one block in a sea of many, many blocks that you want to use to build your house. In contrast, a community tends to be much more engaging, and you can't really maintain more than 5 to 10 communities in your personal and professional life just because of all the time that you spend to engage with them. But you can easily use 5, 50, 100 different libraries when you're making any reasonably large application. So what does a user want from an open source library? What do I want from an open source library? I want to be able to use your library without reading your documentation. If there's documentation, that's great. But I want to be able to just pick it up and start using it because I'm lazy. I want to learn about your library without talking to you as the author, because maybe you're in a different time zone. Maybe you take a few hours to respond to emails. If the information is there and I can find it in 5 minutes, I don't want to wait 3 hours for an email response. I want the library to cater to me when I'm both a total newbie, as well as the same me when I'm expert, both of which are totally different personas. Newbie me wants something that's really easy and quick to get started with, while expert me wants something that's really powerful and flexible. And those are kind of at odds. And I want your library to fix my problem despite you not knowing who I am and you not knowing what project I'm going to use it in. So those are the somewhat unreasonable requests that I would want from an open source library, and presumably most of you would want similar things. They may seem unreasonable, but as a programmer who is lazy and greedy, you want all of it in order to be happy. So how do we get to accomplish those goals? So the 4 facets I'm going to talk about are intuitiveness, which is how you get someone to use your library without reading docs, or to use your library with reading docs as little as possible. Layering, which is what lets you cater to both newbies and experts. Documentation, which is what lets people learn about your library without ever talking to you or seeing your face. And considering about the shape of your library, which is how you can make it fit into other people's projects, despite you not knowing what their project is or who this person is. So all of these are some things that people talk about, very hand-wavy, high-level terms, but I'll try to cover it in a lot more detail to see how can we actually reach these goals. So the first point is intuitiveness. So I think that being intuitive means you can use a library without looking up docs. So any library can be used after you look up docs, no matter how you implement it. But it's a matter of how much you have to look up the docs. And if you have to look up lots and lots of docs before making a simple application or using a single feature, that tends to be very frustrating, especially for newbies. So imagine if you're like doing a whiteboard interview, and you want to do, say, the interviewer asks you to implement enterprise FizzBuzz as part of the interview process. And if you want to use enterprise FizzBuzz, that of course needs a HTTP server because it's enterprise. So the interviewer will then ask you to say, well, you need the HTTP server, but for now, just make up your own library to make HTTP requests to the server. Just assume the server exists and come up with a magic API to talk to a HTTP server, and we'll just move on from there, since we're not in the business of implementing HTTP. So this is something that's very common and in these interviews. And if you totally on the spot make up an arbitrary HTTP client API in any language, you'll probably end up with something that looks something like this. So you import your client package thing, you call get on the URL, and you call get some result object thing that you can pull the JSON out of. And if this is actually Python, the Python request library, the output looks something like that. So the fact that someone who knows about what he wants to do but doesn't know about your particular library would come up with something similar is what makes it intuitive. And the fact that you can, if you show this to anyone, whether they're a Ruby programmer or a Java programmer or a Python or Scala programmer, they'd probably be able to guess that you're pulling some JSON from a HTTP endpoint, even if you don't tell them what this library is without reading any documentation. So that's intuitive. And people really like the request library in Python, which is interesting because it's not a powerful library. It doesn't give you any new capabilities. It's not high performance. It's not asynchronous, non-blocking, not web scale distributed, none of that stuff. It doesn't let you do anything that the normal Python standard library doesn't already let you do in maybe 2 or 3 lines more code. But people like it so much because it lets them do it without needing to read the documentation, because it's intuitive. So if you dig deeper into that, what does it mean to be intuitive? Does it mean that Kenneth Reitz has some magical talent that lets you write intuitive code, lets him write intuitive code? I think that the reason why a line like this is so intuitive to people is it matches what the person who's using this library has used before. So one thing that they've used before is other Python libraries, in this case for Python package. So in many other Python libraries, standard library or non-standard library, you import the package and you just call methods on it to get what you want. That's how things work in Python land, and you can configure it more later if you want to, but the basic API almost always looks like this. And with requests, if you've used a JSON library, then this will look totally familiar to you. You import requests, you make your get, maybe there's some optional arguments you can pass in, and you're done. The other thing that this line of code is consistent with is other parts of the same library. So if you've used requests to make post requests, then using the same library to make a get request would feel totally familiar to you. And if the question then is how do you make a put request or option request, then it's also more or less obvious if you've used these 2 APIs already. The last thing that request API is similar to is underlying data model of HTTP that it is dealing with. So in this case, the mapping from request.get with the URL is pretty close to the actual GET request that goes over the wire with the path, with the host, and all that other stuff that would be in optional arguments on the in your request method will go into optional headers and other things in your actual HTTP request. So that means that because it's so close, even if you don't know anything about Python and don't know anything about this library, you can kind of guess that there's going to be some GET method, and you're going to pass in the host and path somehow. And it turns out that is how you use this library. So that's what I think makes request intuitive. It's not some special talent or magic in the fingers of the programmer, but the fact that it looks similar to what you expect the users to have used before. And the users have used these particular things before. So if you monkey those things and make something similar, they'll be able to pick up your library much more easily. So your library mapping to the other libraries in the space, mapping to itself, and mapping to the underlying model that your library is dealing with, all of which help make things intuitive. So another library that at least I like to think is intuitive is my own FastParse library. So this lets you define a parser using this syntax. So either parser is p, like a.repeat, b or c or d, followed by end of the parse. And you call the thing.parse, and you get the result object. I think this is intuitive because it maps closely to other libraries in the same space that you may have used before. So if you've used a Scala parser combinator library, it looks about the same. Here you have to wrap in a p. Here is .rep instead of rep with parens. But other than that, it's more or less the same API. So all the people come in Scala land who learn parser combinators in the Scala book would be more or less familiar with how this works. It's similar to other parts of itself. So whether you want to repeat, or whether you want to repeat with a separator, or whether you want to make something have a string optional or not optional, it looks more or less like the same library. And you can probably guess, for example, if I want to repeat with a minimum number of repetitions, then you can probably guess you put in an optional argument in the .rep. Lastly, it more or less maps to the underlying model that someone's thinking about when they're using this library. So most people have looked at grammar definitions in some form in the past. And a grammar definition, for example, EBNF grammar, would look something like this. And it's not quite the same. We use .rep instead of star. We use tilde instead of space. But it looks more or less close enough that if you're familiar with the grammar definition, you can relatively quickly figure out how to translate it into a FastParse parser without needing to go through a bunch of intermediate steps. So not everything is intuitive, and even unintuitive things are worth looking at to say, why are they unintuitive? That's very unintuitive. Wait, we are back. OK. So here is one portion of SVT that I think is particularly unintuitive. So SVT overall, some people like it, some people don't. But this portion is particularly confusing, at least to me. And that's when you define, if you want your SVT to generate a file, like for example, a file full of generated source code from your, I don't know, from a protobuf or whatever, then you have a source generated in compile plus equals def.task with the block of what you're trying to generate and a .task value at the end. So I think this is unintuitive. And if you look into what someone coming into this problem would know before, you would see that they know how to generate files in Scala like that. And it doesn't look like how you do it in SVT. So you may have to put this in the middle of the SVT block, but you never had to do this def.task thing before. It's not how you generate files in Scala. They know how to set settings and set tasks in Scala, in SVT. So for example, you can set a name like that. You can add library dependencies like that. Everyone knows how to do that. And in none of those did you have to do this weird def.task thing. And lastly, the underlying model is I want a file to appear at this path in the file system with this blob of source code inside. And if you're thinking about that, you probably imagine I want this path, this source code. And that has no relation to the def.task thing in SVT. So this def.task thing is consistent with SVT's own internal implementation of this feature. But as someone who's coming in to use SVT, they're not likely to be familiar with SVT's internal implementation. So the fact that it's consistent with that thing doesn't help make this intuitive to someone coming to use SVT. So you're not always consistent or inconsistent with everything. So one example I found is with the Akka HTTP server API, where you can put a block with all your get routes inside, you can put a post with all your post routes inside, you can extract things and have multiple routes inside, for example, the extraction. Has anyone here used Akka HTTP before on a server? Did you know you can put print lines in your routes to debug them, like which route it's going to? Did anyone not know you could put print lines in your routes? OK, I guess I'm the only one. Well, so if you want to see, like, for example, what routes it's trying, you can put print lines anywhere in these blocks, and they'll get run and executed when the request comes in. And I think that is surprising to me, because it's very different from how most other routing libraries work. Most other routing libraries, for example, Play routes or Django routes or Ruby on Rails routes, the route code doesn't run every time your request comes in. The route code runs once and generates like a data structure that then gets used every time the request comes in. So putting in for example, putting in a print line in your Play routes doesn't make any sense. Like, even if you could, it'd only get run once. But on the other hand, Akka HTTP is very self-consistent with all the other directives that are in the library. They all behave the same way. And once you learn this small change from the other routing libraries you may be familiar with, the rest of the directives all behave more or less the same. And similarly, the underlying model, which is I want to use some logic to figure out which endpoint I want to run, that makes perfect sense. Like, if you want to use routings, you could use if statements or match switch statements, and it would work just as well. Another example of partial consistency, one that saves the library rather than makes it confusing, is the Python operating system library. So if you look at this library, you see things like os.chdir or getquid or chown. And if you come from a point of view of other Python libraries, no one else writes APIs that look like this. And similarly, different parts of the same OS library are all totally inconsistent. For example, why is it listdir while mkdir instead of makedir? Like, it's arbitrary and inconsistent. But the fact that it is consistent with underlying POSIX APIs is what turns this into something usable, because anyone who's used Bash or used the C or Linux APIs directly would be familiar with all of these terms. So if these weird short abbreviations were not consistent with the C API, they would be totally inscrutable to anyone. And people using it would spend all day looking at documentation. But because everyone who's using it, or many people who are using it, have seen the C API before, they know that chown obviously means change ownership, obviously. And so this becomes something that then can be used without too much documentation. That makes it somewhat intuitive. So like, to me, I think being intuitive is about being consistent with what your user has seen before. And what your user has seen before will change depending on who your target user is. For example, your average Python programmer will know different things from average Scala programmer, who will know different things from average Java programmer. And having, for example, a huge builder initializer would be intuitive to a Java programmer, but not intuitive to a Python or Scala programmer. But in any case, this is, I think, how you make something intuitive. You try and figure out what they've seen before, and you make your thing look as much as the other things they've seen before, such that when they look at your thing, they can know, oh, I know how this works. Like, I've seen this. And they can get started right away without having to look up documentation for every step of the way. The next facet I'm going to talk about is about layering. So layering is how you can provide a simple API for newbies, while also providing a powerful, complex API for the more advanced users. So if you have a library with multiple layers, it may look something like this. You have the API, the first level, where the most important thing is discoverability and lack of configuration. Because the last thing anyone wants to do when you get started with a new project is start fiddling with XML files or JSON config or whatever. Like, they just want to use your thing and see a result come back. Second level is configuration suddenly becomes important, because to actually integrate into whatever enterprise project they're using or in whatever VPN, they're going to need to configure something, and that needs to be possible. Next level, maybe the configurability and flexibility matter the most, and discoverability totally doesn't matter at all. So if someone's been using, for example, your library for the last 6 months and in all sorts of ways, then they already know most of the things that there are to know. And what matters to them is, can I do the thing I want, or do I need to use a different library, or do I need to fork your library and add my own feature? And after that, of course, there could be more advanced layers for more advanced users. So what does this look like in practice? In the case of requests, the beginner level is 2 lines of code. You make a HTTP request, and you get a bunch of JSON about the GitHub events, the events that happen on the whole of GitHub. So easy to get started with, no config, just make the request and go. Next level, you start configuring it, sending up special headers, sending up more data, making post requests. Next level, maybe you need to maintain sessions, so then you start having this session object you need to pass around and deal with that. Next level, you start talking about streaming and can start turning that on and using iterators to read the response or send up the request. But what's important about this kind of layering is you only need to bump into each feature when you need to use it. So if I don't need to maintain multiple sessions, I do not need to care about the session object. In fact, I don't even need to know it exists. I just use request without it, and it works fine. If I don't need streaming, I don't need to care about streaming. I don't have a single word stream in my whole program. I can just use it without streaming and have a simpler API. And when I need streaming later, I can then go and figure out how to use it. But when I don't need streaming, which perhaps maybe the majority of people, if most of people are newbies, then I find it easier for me to get started with without having to deal with it. I think an example of an insufficiently layered API would be something like the Akka HTTP client API, which has a lot of stuff in it to get started. So this is not necessarily a bad layer, but I think this is an insufficiently layered API in that, for example, the actor system and materializer are things that people do want to configure and do configure. So you can't just not let people configure the actor system and materializer. But you also will have a lot of people who don't want to configure the actor system materializer. And even if they want to configure it later, they may not want to configure it now when they just want to get started. So perhaps in that case, they could, like a possible solution would be to have a simple version where you can just make a request with some hard-coded actor and whatever. And later on, if you want to configure it, you then have a second layer API that says, OK, now you can configure it, and how do you want to configure it? Another, I think, example of a well-layered API is the Flask API. There's a Python web server that's very popular by Armin Ronacher. And what's interesting is you can write an application in 7 lines of code that serves a HTTP server. And later on, you're going to need to make it more complex. So later on, you're going to need cookies, your request session, session state, arguments, post bodies, URL parameters, file uploads, all that stuff later. But when you're first getting started with it, you don't care about all those things, and you don't even need to see any of those things. You don't need to think about them. You can get started, and later on, when the time comes to add multi-process concurrency using Unicorn or whatever, you can deal with that later. And for now, when you're getting started, all that stuff isn't in the front to confuse you and intimidate you while you're just trying to get something working. The converse is something like the old Akka HTTP API, which they've since changed slightly, which also is similar to a client in that there's a lot of stuff that is useful to somebody, but perhaps shouldn't be quite the first thing that someone sees when they're looking at your library. This should be the second or third layer of the library when people actually want to configure it. And perhaps there should be a simpler first layer where just to get started with. So they've since added such a first layer, and turns out that apart from a slightly messy imports, your Scala web server can be just as easy to get started with as your Python web server. So it's nothing intrinsic to Armin Ronacher being really good at APIs and programming and making a beautiful API. Everyone can get started with really easily. It's just a matter of properly layering your application such that you have the easy mode, you have the intermediate mode, and you have the hard mode, and people can choose which one they want to use. And everyone, from the most newbies to the most advanced users, will all be able to use your library effectively. So that's what layering's about. You have a simple code for newbies. You have intermediate code. You have more advanced layers. And there's no one API that will satisfy everyone. And the solution is to offer more than one API. So this is a headache to maintain more than one API, like maintain literally two or three different APIs. But if you want a bunch of newbies in a country you've never been before, who have never met you, to start using your open source library, then this is how you make it easier for them to get started and still continue using your library as they get more advanced. The next thing I'm going to talk about is documentation. So the first thing to know is that documentation is a feature just like any other feature in your library. So if you have a beautiful API that lets you write code in a really nice way, but no one knows how to use it in that very nice way, and they're all using it in a very awkward, verbose way, then it's just as good as having a really awkward, verbose API to begin with. So just like any other thing you implement, whether it's improving performance, whether it's scalability, whether it's multi-thread safety, the one thing that you should implement is documentation, just as important. So your users don't want to talk to you, as I mentioned earlier, because talking to you is slow and awkward, especially for those INTJ programmer introvert types. And you probably don't want to talk to all your users either, because they may not speak the same language as you. And if there are 1,000 of them asking you questions, you'll probably run out of time. It doesn't scale. So the first thing to think about documentation is, because it's a feature, the amount of effort you put into it should be proportional to the rest of your application. If you spend 3 months writing a really cool library that does something really beautiful or really awesome in a really beautiful way, you should spend more than 2 hours writing the documentation for it if you want someone to actually start using it. So for example, FastParse, which I think people say has nice documentation, has about as much documentation as main code and test code, which turns out to be a lot of documentation. So this is something like 30 pages of documentation. But if you're going to be writing 30 pages of really intricate Scala library code, writing a bunch of English is usually not too difficult. And it pays off when someone tries to use your library. They can get started very easily without having to ask you lots of questions. And similar for many other libraries. So it varies, but it's within a factor of 5 or 2 to 5. It's not how much documentation you have and how much application code you have. So obviously, this doesn't apply uniformly to everything. It's possible to have a really complex application which is really simple to use, or a complex library that's really simple to use externally. But for many libraries, it's more or less there. The amount of times you spend writing your API, all that needs to be documented somehow. And so you should go and document it. Apart from having enough documentation, just as important is having what I call layered documentation, which is similar to having a layered API where you want something for everyone. And whether that everyone means someone who has no clue what your project is and doesn't know why he should care, to someone who has been using a project for 6 months, giving you lots of feedback and wants to be able to customize it every way he wants. So what does this look like in practice? So in practice, this looks like, for FastParse, intro, FastParse is a parser combinator library for Scala. You thought it was for Python? It's not. If you thought it was a JSON library, it's not. It's a parser combinator library. The newbie topics, once you've already decided how to use that person wants to use FastParse, is this is how you use it. Don't ask questions about why it works, but just this is how you use it and try it out. The next level is things like you are using it, you bump into problems, maybe the performance isn't great, maybe you don't know how to debug your parser when it's broken, or maybe your users don't know how to debug their input when their input to your parser is broken. So all that stuff is things that people will care about, but maybe not at the first step. So that's put later on. And lastly, talking about FastParse's internal implementation, blah, blah, it's an immutable interpreter, grammar transformations, something that maybe 99% of your users don't care about, but quite possibly the 1% that does care is the 1% that's going to be contributing fixes to your library, or the 1% that's going to give you the most valuable feedback about your library. But again, 99% don't care, so it can get chucked right at the end, and the people who need it can find it anyway. Similarly, for my Scalatags HTML generation library, first step, what is this and why should you care? Second step, how to use it, example, 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 example. Third step, more more advanced things that you may or may not care about, but most people probably need one or two of them after they've started using the library. Last step, all the weird implementation stuff that most people won't care, but the people who are contributing fixes would need to deal with. What does incorrectly layered documentation look like? So the old SBT getting started, which they've since improved upon, what is a good example. So this is what a newbie would used to see when you go look at SBTs getting started. So it says, after examining a project, SBT will have a mutable map. Build definitions do not affect SBT's map. The build definition creates a huge list of objects of typesetting, and the type T is a value in the type of value in the map. The setting describes the transformation. Adding new transformation appends it. Returns new map because functional programming does not update old map in place. And the setting transforms the map by adding, and the transform map becomes a new map. So all of this is correct, and all of this is useful documentation for somebody who is contributing to SBT, or someone who is trying to re-implement a competitor to SBT, or someone who is trying to deal with basic SBT's internals. So it's not, what it's not is documentation for a newbie. So it should still exist, but it probably should have put somewhere at the bottom where the advanced people can find it and newbies won't get confused. So luckily, they've improved upon it. So this is a new SBT getting started documentation. So a build definition is defined in build.sbt. That is something that a newbie may not know because they just started using Scala, and Scala uses SBT, and they don't know what everything is. Projects are often called subprojects in build.sbt, which is located in your current directory. Another very important point if you're a newbie. Looks something like this. The subproject has key value pairs, and the key is a name. And in this case, one key is name, and the string value is the thing that gets bound to the name. So no explanation about how it works. No explanation about what the colon equals, how it's implemented, how it's a map or not a map, or immutable or mutable. It just says, here is something, and here's how you use it to begin with. And this is, I think, very good introductory documentation. So that's the second portion of this, the other point about documentation, in that the quantity is not the only thing that's important. So just to take SBT as an example again, SBT has traditionally had a tremendous quantity of documentation, like 50 to 100 pages worth of documentation you print out. It's basically a book on the SBT website. But people found it confusing, especially the introductory pages, because they weren't properly layered. And so they had the really advanced stuff about the SBT's internals floating somewhere near the top where the newbies will bump into them and get confused. So the structure of the documentation, making sure it's properly layered from easiest to hardest, is important to make sure that if a newbie comes to a project, they can quickly find what they want, even though you don't know who they are and they've never talked to you. So the last facet of a good open source library I'll talk about is how to think about the library's shape. So libraries solve different problems. Sometimes there's overlap. Some have more corner cases than others. But generally, each library can be thought of as something that fixes a problem in the design space of the thing that you're trying to build. And you kind of piece them together, ad hoc, pile them on top of each other, and fill in the rest with glue code in order to get something you can sell for a bunch of money, or try to sell for a bunch of money. And if you have other projects to work on, that's when the library becomes useful, because you can put libraries together in different ways in order to satisfy more than one project. And in the end, you don't need to write that much code, only this small bit of orange in each of the project bodies. So what are the failure modes for thinking about about the shape of your library? So one failure mode, I think, is when your library is so perfect that it's totally self-consistent and that there are no corner cases. That's why it's a circle. Ha ha. And in that case, your library, you might find your library doesn't really fit in and do what you'd want it to do in your real project, which actually is full of corner cases. Some of them are really pointy. And you end up having to write a bunch of glue code in order to stitch your perfect library together with a really nasty real-world problem. The other failure mode is if you have a library that is just the glue code extracted out into something called like miscutils, or helpers/helpers.scala, or like Scala extensions 2 or something. And it did everything that needed to be done in the original project, but now you have this awkwardly shaped thing where it doesn't really fit in any new project. It does a bunch of things you don't need it to do, doesn't do a bunch of things you would need it to do, and generally doesn't play nicely with all the other libraries you're trying to use in that project. So that's something that's worth thinking about when you think about your library. Like, where does it fit in not just your particular project, but in the rest of the world? So you don't want something that's too self-consistent, but you also don't want something that's too problem-specific that only works in your particular project. You want something in between that solves some people's corner cases, but is regular enough that you can stack it together and play nicely with other libraries, and play nicely with itself and understandable, so you can use it to build your application. So just to sum up, these are the things your user wants from an open source library. These are things that I would want from an open source library I'm using, in that I want to be able to use a library without reading documentation. I want to learn about the library without talking to the author. If I can talk to the author, it's great, but I don't want to have to talk to the author. I want the library to cater to me when I'm a newbie and don't know anything. But after 6 months of using the library and I'm no longer a newbie, I want it to still cater to me when I know everything and want to customize it in all sorts of ways. And I want your library to fix my problem, despite you never having met me and me not giving you any money. So that's what I want from an open source library. And that's something that actually you can provide without too much difficulty, just with a bit of effort. So you can make the library intuitive by making sure it matches what the expected user will have seen before, whether in other libraries, his previous experience, or the underlying model that the library is dealing with. You can layer the library to make sure it works well for newbies and experts. And you can make sure you have enough layered documentation such that people can learn about the library without having to come and ask you on GitHub channel or email. And lastly, you can think about the shape of the library and where it fits such that you don't end up with a weird misc-utils library that doesn't fit in anyone else's project, or a perfect utopia library that doesn't do anything that anyone really wants. So all of these things are things that anyone can do and don't require any special talent. So especially things like intuitiveness, which are often thought of as something magical that really smart people have. It actually just takes a bit of work to think about what your user has seen before. In this case, your user is a programmer. And try to line up as close as you can to that, such that the person can use their prior experience in order to pick up how your library is meant to be used. So that's 4 facets of good open source libraries. Hope you enjoyed the talk, and I guess I'll take any questions. Anyone? Going once? Going twice?
Of your own libraries, which one would you say is the best example? Or are they all good? Like, which one is your favorite implementation of all these principles?
I think FastParse is really nice. Yeah. Like, many of the others are kind of messy and sketchy and not that well organized. But that one I think is quite nice.
Excluding your own projects, what do you think is the worst example? What would you think is a good counterexample for how not to write this? That nonetheless has become quite enough. There must be one you hate.
A good counterexample. My personal worst would probably be Puppet. Have you used Puppet before, the configuration management library? Like, all of you are laughing already. Like, that's a total hellhole to start using. Yeah, and the documentation, at least when I was using it, came in the form of a PDF you had to sign up for. So and not a great onboarding experience. Yeah?
Can you talk a bit more about how you decide if there's a need for a library and if you want to write it?
How do I decide there's a need for a library, want to write it? Basically, it comes down to having a particularly shaped hole in your house that you're trying to build, and you fill the hole in your own project, and then you decide, well, is this something that's really specific, or is this something that can be generalized to other projects? So most of my good libraries are written with some motivation in mind, and they filled the original goal fine, and I took the extra 10% effort to extract it and make it into a library other people can use. So for example, FastParse was because I wanted to write a parser, and the other parser combinatorial libraries were either too slow or too sketchy. And Ammonite, I needed an IPython-like shell in Scala, so I built it, and it was kind of useful in that own project. And so I ripped it out and published it separately. Yeah. So if you don't have a target shape for your library, it'll probably end up being terrible. And that's just the way it is, because you need some motivation to make the library the way it is. Otherwise, it'll just become ad hoc exploration of all the things you can do, which are infinite. Yeah. Any other questions?
So you seem to have a foot in not just Scala, but Python and JavaScript worlds.
Yeah.
So how do you feel that they tackle these challenges just as a community, if you can help them in that way?
Well, I think that in terms of intuitiveness, the Python people actually do it very well out of necessity. So compared to the Scala world, I feel that in Scala, many APIs are kind of janky, and you can kind of work with them because of all the types. Either IDE will help you, or compiler will tell you and get it wrong, whatever. Whereas in Python world, because everything's so dangerous, people put a lot of effort to try and make things as intuitive as possible because there's no one to help you, and you're there with your intuition trying to figure out how to use the library. And same for things like documentation, which are often much more verbose in like, say, Python land than in Scala. In terms of JavaScript, like, I can't really say. JavaScript is basically like 10 different ecosystems in one language. So each of them has their own like, ups and downs. Like, I don't really think having LeftPad as a library is that great an idea, for example. Yeah, any other questions? Going once, going, yeah.
One of the things I hate is saying, oh, by the way, your foobar library 2.0, thanks for using it, but 3.0 is going to come with a whole new set of abstractions, and you have to like, rewrite your entire code because some religion I got, like everything has to be asynchronous or something like that.
Yeah. Yeah, I don't like that either. I think that for that particular point, which is asynchrony, I think that violates layering in that the dumbest version should probably be synchronous, and then you can use the asynchronous version later. In terms of rewriting the whole code, I think that's unavoidable in some cases because the equivalent is the person just abandons the library and works on a new thing, and it's more or less the same for the end user. Like at some point, the interests are going to change, or necessity is going to change, or something's going to be unfixable and you're going to have to fix it. Sorry, something's going to be unfixable without breaking compatibility, and they're going to need to fix it or want to fix it, and then, oh well, yeah.
How do you think about documentation coverage? So like there's a big gap between the beginning user needing the most basic example and then someone who's ready to start contributing to the project. And like, how do you ensure that you've sort of covered all the common use cases in your documentation?
You can't ensure you've covered the most common use cases, but you can try, which is basically all your APIs should be documented. Every method call you expect someone to use should be either visible in your documentation somewhere in an example, or should be trivially guessable from another API that you're already using. For example, if you have like foo A, foo B, foo C, and you don't document foo D, foo E, maybe that's fine. But generally, I think if you have examples that contain every API in your code base that you expect end users to use, then that already goes a long way to getting people using it. So you have, let's think. So a bit more structurally, at least the way I approach it is, you have the hello world example, which is like a 1 to 5 line thing that people can see and immediately understand, hopefully. You have the unit documentation, which is documentation for every individual API. This is how you use this, how you use this, how you use this. Like some people use Scala.doc for that. Some people put in a separate web page. Mine are all in a separate web page. Doesn't really matter. And then you have a few more like integration docs, which is to say, like, here's a 50, 100 line example of something that you can build with this and using all these APIs. And then that will cover like, quite a good range of total newbie to someone who is using it for reals and wants to see how another person would have written the same application using our library. And then if you're really proud of your really clever internals, you can write about that later. And that covers, I think, the whole range. Yeah. Any other questions? Cool, I guess we are done then. Thank you.